work on different platforms like Windows, Mac, Linux, etc. Python installation. Annapurna Navigator is a desktop user interface. This will allow you to launch applications, manage environments, and other libraries without using command line interface. So this is a preferred option if you want to if you want to run codes in Python when you don't have any online, when you don't have to be online. But here today we'll be using Colab, which is you can. This is a Colab will run online, so we'll be seeing that in the second session. And this is how Anaconda Navigator will look. So we'll see the basic syntax and data types in Python. First, the numeric data type. Python supports 3 different numeric data types like integers, floating point numbers, and complex numbers. Integers are used integers are used for assigned integers. Here, a is a variable which can hold any number, any value. Here, a equal to 100 means a is an integer variable which holds the value 100. You can see that in other, you may know that in other languages like C or C++, where you have to specify what is the data type of the variable. But in Python, you need not specify the data type. You can directly give the variable name and its value. For floating point numbers, you can directly give the variable and the number, floating point number. Similarly, for the complex numbers, here is an example. Next is the string data type. To declare a string, you can give the variable name equal to the string which you want to give in double quotes or single quotes. And why we have 2 different types of declaring a string is because sometimes, right, you may have words with an apostrophe, a single quotes. Like if you say Divya's book, then that you will use a single quote S and then book. So that should not be disturbed here, right? That's why we have a double quote option as well. Next is variables. In Python, you can name a variable in a single letter, or you can give a more descriptive name for it. The rules for the names of the variables are: it should have only alphabets, numbers, and underscores. Your name should not start with a number. The variable names are case sensitive. So capital A is different from a small a. Here is an example. Here my_var equal to a string John. My_var is a variable which holds this string. Similarly, x is a variable holds the value 5. Inputs and outputs in Python. We have input function that will take input from the user. So let's say you type this in your Python script and you run it. Then what happens is this, the string inside input function will be first printed on your screen. So you will have enter your value. Then then it will wait for the user to enter the value. So whatever value you enter, it may be a string, number, or anything. That thing will be stored in this variable. So let's say you type 5, then that number will be stored in input value. But one thing you have to remember is whatever value you're entering in your screen will be stored as a string. So if you want to, then we'll see later how to convert that string into other data types. Next is the print function. This function is used to print specific messages to the screen. If you run this code in your output screen, you can see hello world. Now you may be thinking how to combine text and the string or the variables. For the string variable, you can use plus. So if you run this code, you'll get Python is awesome as the output. Here, y is an integer. Y is a variable having a 5 as a value. So in that, if you want to print this y, then you have to use a comma. So So output will be y is 5. Python also supports arithmetic operations. So one advantage here in Python is you can perform this arithmetic operations in the printing statements. Here you can see the value of a and b are 1. And if I put print of a plus b, then the output will be 2. Next is the comments. Python comments are nothing but non-executable lines of code. Like this is generally used for readability. So here is an example of a single line comment. For single line comments, use an hash. Here a equal to 5 is a variable. So we are writing a comment like variable a stores 5. Python also supports extended documentation capability, which is called as doc strings. Python uses triple quotes at the beginning and the ending of doc strings. So here's an example. You have triple quotes in the start, and you can write whatever you want to, any string explaining the code or anything that the user, the pro developer has to know. Then followed by triple quotes again. Indentation. This is a very important concept in Python. In other programming languages, the indentation in code is only for the readability purpose. But in Python, indentation is used to indicate the block of code. Okay, if you see here, print hello. This is a correct statement. But here we have, there is a space, like probably one tab of space, followed by the print statement. This is not necessary. So this will result. This will, when you compile this code, when you run this code, you will get an error. Here we have an if statement, 5 greater than 2, and this print statement should be present inside the if statements, inside this if block. But we don't have. When here the indentation is not present, so again this will be an error. In the sense, this print statement will not be executed inside this if block. Next is typecasting. Typecasting is a method of changing an entity from one data type to another. Python, it supports int, float, and str functions for converting from one data type to another. Here's an example. Float function of 100. If you run this code, this integer 100 will be converted to a floating point number and stored in x. So x will be 100.0. Similarly, int of any number, or it can be a string as well. So anything which you give, it will be converted and stored in this variable. Similarly, here we have string p variable storing the string 15. So here the output will be 20, 15 plus 5. Here's another example. List in Python. A list is used to store a collection of related data in a single variable. The value stored in a list, it can be of different data types. Here, to declare a list, you have to use square brackets. So you can give a sequence which is enclosed inside a square bracket. If you this will create a list. So here this list will have these values. And you want to create an empty list, then you can, the size of the list, you have to then items of the list by its index. Use the command list of, square bracket index which you want to which anything index can be any number. So I'll just tell for those people who don't know what is an index. Index is it's like memory. Here this every value inside a sequence will have an index. It will start with 0. So item, this value 1 will have index is present at index 0. This one string is present at index 1. This value is present at index 2. So please note that index number will start with 0. So if you give a list name, return this last element in the list. This is you cannot. This is not used in any other language. And Python supports this. So if you want to print the second last element, you can directly give. To replace a value inside a list, you can give list name of the new value. This value will be replaced at the this value will replace the element at an index I. List for adding elements to the list, there are two functions. One is the append value. This will add append function. This function will add this value at the end of the list. For inserting an element at a particular location, use the insert function. For removing an element from the list, you can either use a remove function, which will remove the first occurrence of this value, or you can use pop function, which will remove an element at particular index. For slicing a list, slicing is nothing but you can take a part of the list and create a new list. So let's say I want to create a new list of elements containing the starting index and the ending index. I can give the list name of the starting index : ending index +1. Nested lists are also supported in Python. So here is an example of a nested list. This list has the first row in list has a hello string. The second row has two columns. One is the welcome and next is home. So here I use nested indexing, and list one of 1 will access the first row. I mean here the second row, and here I have 0 of 0 that will that will point to the first element in the second row. So the output will be welcome. Next is a tuple. Tuple is a collection of immutable objects, and the values stored in the tuple can again be of different data types. For tuples, use parentheses. Again, a sequence of values enclosed in a parenthesis will create a tuple. Accessing elements here is same as that of the list. You can either give an index or -1 or -2 based on what element you want to extract from the tuple. To join two tuples, you can give the tuple name, and between the plus, it will directly join these two tuples, and this will be stored as a new tuple. And again, here in tuple also, we can also slice the tuple. This is also very similar to the list, starting index, and give the starting index and the ending index. For nested, Python also support nested tuples. Here is an example. If you want to create an tuple having only one item, then give the item value followed by a comma. You can also have a list inside a tuple. This is supported in Python. And if you want to delete an entire tuple, use the keyword del. So del space the tuple name which you want to delete. One important thing that you should note in tuple is you cannot change, add, or remove elements inside a tuple. So dictionary is an unordered collection of key value pairs. Declaration of dictionaries, you can use curly brackets. And here's an example. Here 1 is the key, and this key has value 1 as one string. And to create a dictionary, you can also use dict function. Inside, you have to give the sequence. This will create a dictionary 1 as a key and value as 1. The important properties of the dictionary keys are the keys are duplicate keys are not allowed. Keys are case sensitive. The keys must be immutable. So you can use string, number, or tuple, but you cannot change it. Adding new items in the dictionary, you can give dictionary of the key equal to value. So this will create a new item having this as key and this as the value. Python also supports nested dictionary, and here is an example. Here, this second item in the dictionary has the dictionary as a value. You can access elements in the dictionary by using the key. So dict name of the key will return you the value for the key. For removing an item, you can use the del keyword, del space dictionary name of key. To extract all the keys in the dictionary, use the keys function. Dictname.keys. This will return you the list of the keys in this list of dictionary keys. To get the value, use values function. This will again return a list of dictionaries values. For extracting both keys and values, use the function items. This will return a dictionary's key value tuple pairs. Next is a set. Set is an unordered collection of objects. This set is basically modeled based on the sets in mathematics. So as you all know, you cannot have multiple occurrence of the same element in a set. So here is a declaration. Set name of curly braces, inside that give the sequence. You can also use set function with parameter as the sequence, as any sequence. Here is a list, but you can see this list has multiple occurrence of the same element postcard. So when you execute this, your set name will have only these three strings. This will be eliminated. And you cannot access an item, a particular item in a list, in a set. You can use a print function and you can see what are all the elements present inside a set. Python supports all the, most of the functions which you do manually in a set. So as you can see the disjoint, subset, and difference, union, all those things are supported in Python. You can use these functions. Conditional statements. Python supports the usual logic conditions from the mathematics. For equal, use double equal to symbol. The output will be either true or false. Not equals will be A not equal to B. Less than or equal to, greater than equal to. These conditions will be mostly used. First is the if statement. We'll see the syntax of if first. If here, whatever I have colored in blue are the keywords, or the basic syntax of the statements. The color, the text in yellow can be replaced with whatever you want. So here, if is the keyword followed by the text expression, which are basically the conditional statements. Then you have to give an tab of indentation. Then you have to write the sentences which you want to execute inside this if block. And so how if statement works is, first Python will run the condition statement, which will check whether the condition is true or false. If it is true, it will execute the statements inside the if block. If it is false, it will not execute these statements and the control will go back to the next statement. So how will the Python know when the body of the if is ended? So Python will take the first unintended line as the end of the if loop. You can use integers instead of text expression, instead of any conditional statement as well. So Python will interpret non-zero values as true, and if you give a none or a zero, that will be interpreted as false. Here we have an example of if statement. A equal to 33, B equal to 200. First, if A greater than, if B greater than A, this will check the condition. Here it is true because 200 is greater than 33. So output will be B is greater than A. Next is if else statements. Here, if, then give the test expression, then the body of if. After that, you don't have to give an indentation. Directly give the list else keyword with the colon. Check the statements which you want to execute inside this else block. So how if else work is, first it will check the test expression. If it is true, Python will execute the codes inside the if block. If it is false, then it will execute the code inside the else block. Here is an example. If B greater than A, here it is false because 33 is less than 200. So this line of code will not be executed, and the control will come to else block, and it will execute this command. Next is the if, elif, else statement. The keywords are if, elif, and else. First, test expression will be checked. If it is true, body of if will be executed. Sorry, body of if will be executed. If it is false, then the test expression which you give inside the if elif block will be executed. If that is true, then the body of elif will be executed. If that is also false, then the control will go back to will go to the body of else. You can have multiple elif statements, but the elif statements should be followed by the else statement. Here is an example of elif. Here A and B are equal, so this condition is false, and this condition is checked now. It is true, so output will be B and A are equal. Next is the loop statements. In programming, a loop is a sequence of instructions that are continuously repeated until a certain condition is reached. Python supports two types of loop commands. One is for loop and another one is while loop. For loop is used to iterate over a sequence. It can be a list, tuple, or a string, or any other iteratable object. And iterating over this process of iterating over sequence is called traversal. The syntax of for is for variable in any sequence, then a block tab of indentation, then you write the body of for. This val is a variable. This will take for every sequence. This will take a value. This variable's value will be an item in the sequence. Loop will be it will continuously run until we reach the last element in the sequence. Here is an example. Fruits equal to apple, banana, and cherry. For x in fruits, so what happens is for the first iteration, x will take the value apple. In second one, it will take the value as banana. Third, it will take the value as cherry, and it will print these values. Once once x becomes cherry, and in the next iteration, we don't have any other value inside this sequence. So the control will go back. It will come out of the for loop and it will go back to the next statement. Then here is an example for x in banana. So here what happens is in every iteration, x will take a character. The value of x will be a character in this string. First it will be B. In the second iteration it will be A, and it will go on. Next is for loop with range. A sequence of numbers can be generated using this range function. So if you want to generate a sequence of having numbers from 0 to 9, you can directly use the function range of 10. This range has 3 parameters. First is the starting number, second is the stop number, then the step size. Default step size is 1 and the default start value is 0. So an example of range function, here range of 2, 23. So first value will be 2, then next value will be 2 plus 3, that is 5. Then it will go on until 17. 17 plus 3 is 20, but this even stop value, Python will not when 17. Next is an example of range in the for loop. Here the range of length of style. Here length of style will return 3. So basically this line is for I in range of 3. So it will generate a list of having values 0, 1, 2. So I will take values of 0, 1 and 2 in each iteration. Next is the while loop. A while loop is used to iterate over a block of code as long as the test expression is true. Here this is a syntax, while of test expression, colon, then a tab of indentation and the body of while. So we use this while loop whenever we don't know the number of times you want to iterate this codes. This is an example of while loop. Okay, first we'll see how while loop works. So here control enters the while loop. It will check the test expression. If it is true, it will run the body of while. This will keep on happening until the test expression returns false. So in this example, n is 10, I is 1. While 1 less than or equal to 10 is true, so it will go inside this while loop, and I will be incremented as 2. Then then the while loop will check whether I is less than or equal to n, 2 is less than or equal to n, so the condition is true. it will run the next statement. This will keep on going till I becomes 11. So in loops, we iterate over the block of code until the test expression is false or it reaches the last element. But what if sometimes you want to terminate the code before it? So that time you can use break or continue statements to alter the flow of the normal loop. So break statement will terminate the loop containing it. So whenever you have a break statement inside this, we have why you might be thinking when I'll be using this break. So means this loop will be executed infinite times. So at some point of time, I should exit the loop. So that time, here we're taking the input from the user. If he press 0, we have to exit the code. So that time we'll check whether I equal to 0, and if it is true, we'll break. So the control will come out of the program. I mean, here we have only this code as the program, so it will come out of the loop as well as the program. If it is not 0, then you print the square of the elements. Next is a continue statement. This continue statement is used to skip the rest of the code in the body of the loop. So let's say we have a test expression of the loop. It is true, and we have a continue statement. If it is present, then the codes which are present below it will not be executed. I mean, the code inside the loop or below this continue statements will not be executed, and the command will go back to the test expression. So the iteration stops there and goes to the next iteration. So here difference between continue and break is, here in continue the loop is not terminated, it will just go to the next iteration. For example, here integers is a list having 1 to 5. We'll check whether I is equal to 3. If it is true, then it won't process the statements. It will go to the next iteration. If we didn't have if we don't have any, if I is not equal to 3, then you can do some processing on the variable. So this completes the data types and basic syntax in Python. Now I request Vidatri to take over the presentation.
Yeah, thank you, Divya. I'll share my screen. Please let me know when you can see. Hello, am I? Okay. Before continuing with the presentation, I just wanted to let you know if any of you have any questions. We have shared a Google Doc in the chat. If you can access it, please type out your questions over there and we'll answer them parallelly.
I'll share it to mail also if it's not enabled, because chat is still not enabled.
Oh, okay. Yeah,
Okay.
that should be fine.
Like, were people able to see the chat at least, or it is not visible? Just a minute. Vidatri, just a minute.
Yeah, sure, sir.
Yeah, like I wanted to know whether people were like able to see the chat. If not, please let us know. You can unmute yourself now.
Hello, sir. We are not able to see the chat itself.
Okay, ma'am. Like it
It's
should
not
be enabled by
ma'am.
admin. It will be done by tomorrow. Okay.
Okay. Okay, sir.
And you would have preferably received attendance sheet and PPTs, right, ma'am?
PPTs, let me check, sir. We have received the PPTs, sir.
Okay.
And even attendance also.
Yeah, thank you so much.
Excuse me, Santosh sir. This is Archana H. Sir, I have
Ma'am.
not received the attendance sheet, and I had sent a mail also regarding this to Mercy ma'am.
Yeah, I have
Again, you have been invited to fill the form. Still, you didn't get?
No, no, ma'am.
Like, your personal ID, I have invited you.
Okay,
Ma'am, it's archana.suk@manipal.edu, right, ma'am?
Yes, yes, ma'am. Yes, yes, sir.
Yeah. Could you please check again, ma'am, if you don't mind?
Okay, okay. Thank you, sir. Thank you.
Yeah.
Yeah, so Divya has given us a very good understanding on the basic constructs of and operations in Python. Now we'll look into some other capabilities of Python which will help us efficiently solve. First, okay.
Yeah, because they sent in chat parallel. If they have any doubts, they said they can put it there. Yeah. Sivaselvan B ATAL workshop. Will not be able to do.
Okay. So function is a group of related statements that performs a specific task. If you have a prior knowledge of programming, you will know how useful the functions are in any programming language. So it will help us break our program into smaller modular chunks so that it can be easily manageable and organized. Functions also avoid repetition of the code and makes the code more reusable. This is the syntax of functions in Python. So before the function name, we'll start it off with the keyword def function name, and in parentheses, all the parameters. Parameters are the input arguments for the function, and followed by a all the statements which come under this function should have a one tab space of indentation in it. Here is an example. Here I have a function greet. So to define the function, I'm using a keyword def greet, and it takes the input argument name. And when this function is executed, it will print hello and the name that is passed to the function, and good morning. So from the main function here, when I call greet of Paul, this will print hello Paul, good morning. Next, return statement. In a function, return statement is used to exit the function and go back to the place where it was called. You can also return some variables which are the outputs of the function as well. Unlike many of the programming languages, Python allows you to return multiple variables from within a function. Here I have an example. This function powers of number returns the square of the number and cube of the number. So when you want to return multiple variables, we just need to give a comma separated list. And to call this function here, squared comma cubed equals to powers of 3. This will return the square value to the squared and cube value to the variable cube. And this is the output that you'll be getting here. If a function is not returning anything, then by default, Python will return a none object. So this is how the control flow works in Python, just like any other programming languages. In your main function, whenever the interpreter sees the function name, the control will be transferred to the function definition, and the statements within the function will be executed. Once it sees the end of the function, the control will be given back to the next statement after the function is called. There are two ways to call a function in programming, usually call by value and call by reference. In Python, when you pass an immutable argument like integer, string, or tuple to a function, then it acts as a call by value. That means you can modify the way, if you modify the input variable within the function, it will not be applicable to the main function. For example, here there is a function make me rich, which takes in the input argument balance and gives it the value 10 lakh. And in your main script, you have the account balance as 500, and if you call the function make me rich with the account balance, here inside the function balance will be 10 lakh, but once the control comes back to the main function, account balance will still be 500. The other method to call the function is call by reference. In call by reference, usually the address is passed as an argument to the function. In Python, whenever we pass a mutable argument like list, it behaves as a call by reference. Here, in this function, it takes an argument A and gives first three elements of the array of the list will be made 5, 6, and 7. So in my main function, I have defined A as 1, 2, 3. But once I call this function and this function is executed, at the end, if I of the main function, if I print the A, it will print 5, 6, 7. So here, since list is mutable, the values, if it is modified within the function, it will be modified in the main function as well. Another new capability within Python is the usage of lambda functions. Lambda function is used for creating a small one-time anonymous function objects. This is the basic syntax of lambda function. Lambda keyword, then the arguments to the function, colon, and then expression. This expression is executed and the result will be returned. A lambda operator can have any number of arguments, but it can have only one expression. It cannot contain a block of statements. This returns a function object which can be assigned to any variable. So for example, here, this is a normal function in Python. Add, here we are defining add with the two inputs A and B and returning the value A plus B. Now, if we want to use the same with the help of lambda functions, we can do it this way. Add equals to lambda, this keyword, then arguments A comma B, colon A plus B. This will return this will execute this expression A plus B and return the value. So when we do print of add of 2, 3, this will print the value 5. Another important concept in Python is modules. Python allows adding definitions of functions in a file and use them in a script or in some other script or an interactive instance of interpreter. Such a file is called module. Module usually contains a set of related functions. For example, if you want to have a module called sort, you can have all the different sorting algorithms like insertion sort, bubble sort, quick sort, etc. in them, and you can import the module itself into some other program that you are using. Standard libraries in Python is a set of standard modules that are described in a separate document called Python library reference. Some of these modules are built into the interpreter. These are not the part of the core language, but then they are built in for the sake of efficiency or for to access some operating system primitives such as system calls. Some of the standard libraries in Python are sys, math, random, and statistics. There are many more standard libraries that you can find if you search in the documentation. So how to use the standard? Here, if you want to import the library random and use some of the functions within the library, at the beginning of the script, you need to add a statement called import and then the library name. Here it is random. Once this is imported into our interpreter instance, we'll be able to use all the functions that are there in this standard library. Here, this is a function within the random library called randint. This will return an integer in between 1 and 100. Other than the internal libraries that are built in there, you can also install some external libraries for according to our requirement. To install external libraries, the most commonly used method is pip. Pip is the package installer for Python. You can use pip to install packages from Python package index or any other indices. So here is an example on how to install a package. You write pip install and the library name that you want to install, here matplotlib or pandas. This is a one-time installation, so you install it before using it for the first time, and then later you can just import these libraries into the script whenever needed. I'll go over some of the important libraries that we'll be using for data science throughout the course of this workshop here. These are also some of the most basic libraries that are used when someone is performing data science or data analytics with the help of Python. One such library is NumPy. NumPy is a library which adds the support for large multidimensional arrays and matrices. Along with that, it has a collection of a lot of functions which operate on these arrays. Why NumPy is a very important library is because it is used for high performance vector and matrix computations. And it provides a set of pre-compiled functions which are optimized for numerical routines. And the algorithms are also optimized for supporting vectorized computations. Let us look at some of the functions in the NumPy library. To import the NumPy library into your script, we'll use import NumPy as NP. Here, as NP is used as an alias to NumPy, you can use any other name as well. To define an array, you use array name equals to np.array of a list of numbers. Here, 1, 2, 3. This will define an array with values 1, 2, and 3. And if you want a 2D array, you can use np.array of give a nested list with 1, 2. This will be the first row and this will be the second row. Here is an example. So arrays, here we are defining an array with the values 1, 3, 6, and 9. You can do ARR plus 1, which will increment each of these elements by 1. So this will be 2, 4, 7, and 10. Also, there is a inbuilt function to sort the array. The sort function, which is called np.sort. The sorting is by default in ascending order. There's a function to get the sign of the values as well. there are many other functions such as exponential, square root, etc. You can look it up in the library documentation of NumPy for all the possible functions. NumPy is also used for 2D matrix operations. Here I am defining an array, 2D array A with the values 1, 2, and 3, 4, and another array B with the values 5, 6, and 7, 8. So when we do an A plus B, this performs an element-wise matrix addition. And A into B, A star B will give the performs element-wise matrix multiplication on it. A dot of B is a function that is used to perform regular matrix multiplication that we learn in linear algebra in general. So 2D arrays can be sorted based on the row-wise or column-wise. This axis argument is used to determine whether we want to sort the array row-wise or column-wise. Here, if axis equals to 0 is given, then the array will be sorted based on row-wise, and if axis is 1 is given, then columns of the array will be compared, and then sorting is performed. You can also determine which kind of sorting algorithm that you need to use here for sorting. Here kind is given as merge sort, so this will perform a merge sort, but instead we can give quick sort or any other sorting algorithm as well. Again, there are many other operations for 2D array as well as n-dimensional arrays in the NumPy library. Another important library for data science in Python is Matplotlib. Matplotlib is a plotting library for Python. It's a numerical mathematics extension of NumPy. It provides APIs for embedding plots into applications using GUI toolkits. Matplotlib has again multiple modules, and PyPlot is a very important module in the Matplotlib library, which gives MATLAB-like interface. Matplotlib is designed to be as usable as MATLAB with the ability to use Python, and the advantages it's free and open source. Matplotlib is used to generate 2D and 3D scientific plots, and you can save the plots in many formats like PNG, PDF, SVG, etc. Yeah, so two main modules in the Matplotlib library are PyPlot and PyLab. PyPlot is a module within Matplotlib that provides access to plotting libraries. And PyLab is a convenience module. It combines both the functionality of PyPlot and NumPy. So you don't need to import NumPy separately. If you import PyLab, NumPy will also be imported. But it is not recommended to use PyLab. It is recommended to use PyPlot instead. Now I'll go over some of the examples with Matplotlib. To import Matplotlib, we use this statement: import matplotlib.pyplot as PLT. Here I am importing NumPy as well, and I am defining an array with the function np.linespace. Here this function will create an array of length 100 with the values equally spaced values between 0 and 10. And I am taking exponential on minus a. So this will give e power of b will have the value of e power minus a. Now to plot this, if we use the function plt.plot of a comma b, a will be the x-axis and b will be in the y-axis. You can also add labels and title for the plot. We'll be showing that later. And to visualize the plot, we use the function plt.show. Here is another example for histogram. Here I am defining x as a normal distributed value with size 200. So this function, normal of size equal to 200, will create a Gaussian distribution with 200 samples. And to plot a histogram on this value, we use the function plt.hist of x, which is the value, and bins is an argument which is used to define how many bins you need. Here, since there are hence we have given 30, this plot will contain 30 bins. Again, to visualize the plot, we use the function plt.show. The next example is a scatter plot. Here we are defining two random numbers between 0 and 1 rand with sample size 100. So A is a 100 length array with the elements between 0 and 1, and similarly B is also an array of length 100 with elements between 0 and 1. Now to find the correlation between A and B, we can use the scatter plot with the help with this way. So plt dot scatter of A comma B. Again, visualizing is with plt dot show. This is an example of pie chart. So we have 4 labels: frogs, hogs, dogs, and logs. And here we have defined the percentage of each of these labels. So frogs is taking 15% and hogs 30, so on. Here the explode is a variable that is used to define if we want one part of the pie chart to come out of the circle this way. So if you want it to come out, you give a value which is greater than 1. Explode is a tuple. It will have you can define the values here based on your requirement. This will give us plt.subplots will give an axis with give an axis and a figure. Now on the axis we'll plot a pie chart use the help of function ax1.pie. Sizes, which defines how much of the percentage each of them is taking. And explode is an optional argument. You can either give it or not. Labels equal to labels will give take the labels for each of these sizes. And shadow is used to give a shadow effect on the pie chart. Again, this is an optional argument. ax1.axis equal to axis of equal is used to make the axis size x and y axis as equally sized. Here also we'll use plt.show to visualize this plot. There are many more functions with pieplot, like you can use subplot here. Fig.add subplot of 2,211 will define a figure with 2 plots, 2 rows of plots and 1 columns, and this will return the axis for the first plot. And you can also add the legends to the plot or set the X label or set title. So far whatever we've been doing with visualizing or with NumPy arrays, we define the data internally. But when we go to a real life problem that we'll be solving, the data is usually available in the form of a CSV file or a text file or an Excel sheet. So we need to read these files into into the Python environment and perform analysis on those. So there are some existing libraries in Python which help us do this. One such famous library that we'll be focusing during this session and the workshop is Pandas. So pandas helps carry out entire data analysis workflow in Python without having to switch to any other language. It offers data structures and operations for manipulating tables and time series. There are various library features. I'll go through them here. Uh, it, it provides a fast and efficient data frame object for data manipulation. A data frame object is almost identical to a dictionary object, but you having it will give a tabular format for the data. And Pandas library has tools for reading and writing data between in-memory data structures and different formats like CSV file, text files, or Excel files. It also has intelligent data and alignment, and it has integrated handling of missing data. It also allows us to reshape and pivot data sets. In a pandas data frame, columns can be inserted or deleted from the data structure for size mutability. You can also do aggregating operations like group by, which we have in SQL. Similar powerful engine is available in pandas data frames as well. It also gives high performance merging and joining of data sets, and it provides capabilities to filter the data. Now I'll go over some of the functions that we'll be using in pandas. So to import pandas, we use import pandas as PD. Now here, after the import is done, here pd.data frame of D will return a data frame. Here D can be either a list or a dictionary. A data frame is a two-dimensional data structure which is aligned in a tabular fashion. You can also read the CSV file here. pd.read CSV of file name will read the data from the file name and convert it into a data frame object which we can use for analysis in our code. Once the data is read into the data frame, you can check the data types of each of the columns in the table with the help of the function df.dtypes. You can print the first few rows of the data frame with the help of the function df.head_2. Here, instead of 2, if you give the argument n, this will print the first n rows of the data frame. The tail function is used to print the last n rows of the data frame. Okay, here we have a data frame which has 3 columns, 1, 3, and 2, and each of these columns have 4 rows in it. So the function df of column name dot describe will give the total count and the number of the unique values and most occurring elements in that column. Here again, df dot locate of a, LOC of a will find the value based on the index. So here, since we have given a, which is this index, it will return this row 1, 10, and 1. Instead of using index, you can also use the integer position. iloc is used to get the data frame based on the integer indexing. So here df.iloc of 0 to 3 will return the first 3 rows of data frame. And you can access the entire column using the column name, similar to dictionary. So here columns names can be equated to the keys of the dictionary, and df of 1 will return 1, 2, 3, and nan. You can also find some values based on the index and row. So df dot of a comma 1 will return the value at index A and from column 1. So this will return 1.0. And instead of using this index, we can also use integer based index, and for that we use the function iat. Iat of 00 will again return 1.0. Pandas pandas also handle null data, so you can use the function df.isNull to check if any of the values are null in the data. So it will return true if the value is nan. If it is not, it returns false. So for this data frame, all this will be true, but in the last row, the first two columns will be returned true, will have the value true. You can fill the NaN values with any other values that of your wish. So here, for that, we can use the function fill_NA. Here, we are filling all NaNs with the value 0. In pandas, you can also query some of the based on some condition. So if you here for that we use the function query. Here df.query of 1 greater than 0 will return all the rows in which the value of column 1 is greater than 0. So if so for that here these two rows will be returned. Apply map is a function in pandas which applies any function to each of the element in the data frame. So if we do df.apply map of np.square root, it will take the square root of each of the element within the data frame. Pandas also has another data frame, another way of handling data called series. Series is a one-dimensional labeled array which is capable of holding data of any type. So you can say that data frame is a collection of series. So each of the column of a data frame can be considered as a series. These three are the most important libraries that we'll be using. Other than that, there are few other libraries in Python. One of them is scikit-learn. Scikit-learn is a machine learning library for Python. It has various classification and regression and clustering algorithms like SVM, random forest, gradient boosting. We'll be looking into this in the coming days of the workshop. To install this into your machine, you can just type pip install sklearn. One more important library is mlextend. Mlextend is most frequently used for pattern mining algorithms. To install mlextend, we use pip install mlextend. Now that brings us to the end of this session. So we've learned the basics of Python programming language and some of the most important modules we'll be using during this workshop. This will actually give the groundwork for the next couple of days. In the next session, we'll be doing a programming session and where we'll use all these concepts that we've learned and try to solve some problems. I'll be sharing this presentation for the reference. Now we can, if any of you have any doubts, you can ask them. Thank you.
I guess participants can mute yourself and then talk in case if you have any queries. And if there are no queries, we will have a break now and for the lunch, and then session again starts with the practical session by 2:30. See to it that you will join the same meet at least by 2:25. Thank you.